Hello, our dear grade 10 learners. Blessed are to you and to your parents or your guardian. Welcome to Tirad Pass Network, DepEd Candon City Teleskwela, Kanlungan ng Kaalaman tungo sa Kausayan at Kaunlaran. Tara na! It's mathematics time again. I am sure you are excited and very eager to learn the lesson for today. This episode is for grade 10 mathematics, quarter 2, week 2. I am your teacher, She, and I'll be your teacher for today's episode. Are you ready to learn while having fun? That's good! Let's begin! This week's episode in quarter 2 is anchored on the most essential learning competency, which is to solve problems involving polynomial functions. In today's episode, you are expected to solve geometric and population problems involving polynomial functions. To achieve this objective, please be guided by the following questions. First, what are the solutions of geometric problems involving polynomial functions? Second, how do you solve population problems involving polynomial functions? First, let us recall that a polynomial function is a function that can be written in the form f of x is equal to a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus a sub n minus 2 times x raised to n minus 2 plus until a sub 1 times x plus a sub 0, where a sub n is not equal to 0. N is a positive integer and the coefficients a sub 0, a sub 1 until a sub n are real numbers. Let us have a geometric problem as the first example of the application of polynomial functions. The students of grade 10 Circon were instructed to construct a wooden broom box as their group project in geometry. The volume of the box is given by the polynomial function f of x is equal to x cubed minus 6x squared plus 11x minus 6 cubic meters. Aldrin, one of the members of the group, could hardly identify the possible dimensions of the box. Help him solve the problem. Based from the given problem, what is the volume of the box? Correct! It is f of x is equal to x cubed minus 6x squared plus 11x minus 6 cubic meters. Then, how would you find its dimensions? To find the dimensions of the box, we need to use the process of synthetic division. Simply revisit our previous lesson on synthetic division in quarter 1. So, first, let us identify the numerical coefficients of the given polynomial function f of x is equal to x cubed minus 6x squared plus 11x minus 6. These are 1, negative 6, 11, and negative 6. Then, let us choose our trial divisor from the factors of the constant term negative 6, which are positive negative 1, positive negative 2, positive negative 3, and positive negative 6. Let us try positive 1 as our trial divisor. Doing the synthetic division process, we bring down 1. 1 multiplied by 1 is 1. Negative 6 plus 1 is negative 5. Negative 5 multiplied by 1 is negative 5. 11 plus negative 5 is 6. Then, 6 times 1 is 6. Negative 6 plus 6 is 0. Presto! The remainder is 0, which means that our trial divisor is a root or a 0 of the given polynomial function based from the concept of factor theorem. Continue the multiply and add processes of synthetic division using the numerical coefficients of the depressed equation. Thus, we have 2 and 3 as the other roots or zeros of the polynomial function that describes the volume of the broom box. What does our solution mean? It means that the roots or zeros of f of x is equal to x cubed minus 6x squared plus 11x minus 6 as representation of the volume of the broom box are also the dimensions of the box. Thus, the dimensions of the broom box are 1 meter by 2 meters by 3 meters. Did you get it? Very good! Let us have a problem on population. The population P of a town T years from now can be modeled by the function P of T is equal to 6t raised to 4 minus 5t raised to 3 plus 200t plus 12,000 as foretold by a demographer. Predict the population of the town 2 years from now. What is the solution of the population problem involving polynomial function? Simply evaluate the given function that models the population of the town at t equals 2. In the given function, p of t is equal to 6t raised to 4 minus 5t raised to 3 plus 200t plus 12,000. Simply substitute t with 2, then evaluate. Thus, we have p of 2 equals 6 times 2 to the 4th power minus 5 multiplied by 2 cubed plus 200 times 2 added to 12,000. Simplifying it, we have 6 times 16, that is 2 to the 4th power, minus 5 times 8, the result of 2 cubed, plus 200 multiplied by 2 plus 12,000. Further, we have 96 minus 40 plus 400 added to 12,000, and P of 2 is 12,456. What does this mean? Yes, you are right. It means that the population of the town represented by the function P of t is equal to 6t raised to 4 minus 5t raised to 3 plus 200t plus 12,000 will be 12,456 people 2 years from now. Were you able to follow the solutions of the problem, our dear learners? That's great! After solving these problems, do you have now an idea about the solutions of geometric problems involving polynomial functions? Also, how do you solve population problems involving polynomial functions? To answer geometric and population problems involving polynomial functions, you must follow these steps. First is to read and understand the problem. Then, devise a plan. Third is to implement or act your plan. And lastly, check if your answer is correct. All right! Now, it's your turn to solve problems involving polynomial functions by doing the activity entitled Solve na ako sa'yo. You will have 30 seconds to solve each problem. Number 1. A certain strain of bacteria has a population that can be modeled by the function f of t is equal to t raised to 4 plus 6t raised to 3 minus t squared minus 6t, where t is in hours. compute the population of the bacteria after 3 hours. Your time starts now! Time is up! Compare your answer in number 1 with what is being flashed on the screen. Did you get 216 for item 1? You are right! After evaluating f of t at t equals 3, the value of the function is 216. It means that there are 216 bacteria in just 3 hours. Very good! Number 2. A rectangular prism is x plus 7 inches long, 2x plus 1 inches wide, and x minus 2 inches high. Letter A. Write the volume of the box as a function of x. Time is up. Let's now check your answer. In number 2, letter A, is your solution the same as this? Were you able to compute the volume of the rectangular prism? That's it! The volume of the rectangular prism as a function of x is v of x is equal to 2x cubed plus 11x squared minus 23x minus 14 cubic inches. Perfect! Let's proceed to item number 2, letter B. What is the volume of the box when x equals 3? Have you finished solving the problem, our dear students? Compare your solutions in item number 2, letter B, to what is being flashed on the screen. Is your solution and answer the same as this? What is the numerical volume of the same solid when x is equal to 3? Correct! It is 70. For the interpretation of our solution and answer, the numerical volume of the rectangular prism is 70 cubic inches. Did you get them all? Excellent! Indeed, you are a superb problem solver. That's it! We have reached the end of the lesson. In life, there are many problems that we may encounter, so always bear in mind that in every problem, there is always a solution. Thank you very much for tuning in. If you wish to read related topics in our lesson, feel free to browse these references. I hope you learned a lot from today's episode. Always remember the inspiring yet challenging line of James Jelf that life is a continuous exercise in creative problem solving. So, keep on solving creatively and wisely, our dear learners. Once again, I am your teacher, She, saying keep on praying for a healthy and safe 2021. See you next time!